All right, welcome to day 7, our review day. So if you could have your Unit 8 problem set out, the sub will come around and collect that as we are going over the homework. If you do not have it completed, make sure to have it completed for tomorrow to minimize the number of points that you will lose for it. So we'll start talking about number 1 on the homework. So from our givens, we had AB congruent to BC, and with our right angles in step 3 there, we can do right angles implies congruent angles. The congruent angles are D and B. We're then one thing short, so we'll do reflexive property, AC congruent to AC. But the thing we currently have is an angle that is not between the two sides. We currently have side-side angle. Back in Unit 7, that was a big problem. In this unit, if the angle is a right angle, we are okay. We just need to do one extra step. In step 5 there, we're doing our right angle implies right triangle. In the statement, we state that the two triangles are right, and then we can finish off with hypotenuse leg congruent to hypotenuse leg to get the triangles congruent to each other. For number 2, we had a set of congruent sides. We had some right angles, which could imply congruent angles. And we got a midpoint that can imply two congruent segments. Again, we have an angle that is not in between two sides. So we have side-side angle, which doesn't work on its own. But if the right angle, or if the angle is a right angle, we're going to be in good shape. So in step 6 there, we again do right angle implies right triangle. State that the two triangles are right, and we can finish off with hypotenuse leg congruent to hypotenuse leg and have the triangles congruent. For 3, we have one set of sides congruent. We've got perpendicular lines, which can imply right angles, and then right angles implies congruent angles. I numbered them in my picture 1 and 2, and in talking about them in the statement. We had a midpoint that can imply two congruent segments, so we get RT congruent to TV. Just like the other ones, we now have two sides and the angle is not in between. That on its own does not work. We should never be writing SSA in a proof. But because the angle is a right angle, we can do right angle implies right triangle. We've got in the statement 8 that the two triangles are right, and finish it off with the two triangles are congruent by HL congruent to HL. All right, on page 33, we're going to hold off on proof 1 for a second, and we're going to start off on proof 2. So notice our prove, eventually we want to prove a couple segments congruent. So our goal is to get the two triangles that contain those segments, which in this picture there only happens to be two triangles. But we want to get those two triangles congruent, and then we'll do our one additional step. So take a minute or two and get down your 5 givens, and once you have them down, mark up the things that are congruent in your picture. So one of the things we have congruent is BC congruent to CD. So I'm going to put a tick mark on those. There's a set of sides congruent in our triangle, so that's great. We have angle 1 congruent to angle 2, so I'm going to put an arc on each of those. And we should be a bit curious. Why are they giving us angle 2 when angle 2 is not actually in our triangles? From our givens, I'm going to next work with the perpendicular lines. So from our original yellow card, we know perpendicular lines implies right angles. A, B meet at B, and C, D, and D, E meet at D. So because it's just a single letter there, I'm just going to use the single letter rather than numbering them. So we got angle B and angle D are right. Automatically after that, we'll do our right angles implies congruent angles. So that's going to be angle B congruent to angle D. And when we mark those congruent in our picture, we want to make sure we mark them with a box. So now we have a side and an angle congruent in those triangles. Our last given there, we have an angle bisector. It's BCE. So here's angle BCE. So the two little angles would be the angle 2 and the angle 3. So we'll, as reason 8, we'll do our angle bisector reason. Angle bisector implies two congruent angles. And that'll give us angle 2 congruent to angle 3. So I'm going to mark those with double arcs in our picture. And what we want to notice is that angle 2 got marked up in two different ways. So that means there's two angles that are congruent to angle 2. Whenever there's two things congruent to the same thing, we should be using our transitive property. We want to focus on steps 4 and 8. In step 4, angle 1 is congruent to angle 2. In step 8, angle 3 is congruent to angle 2. So the conclusion we can now make is angle 1 is congruent to angle 3. So I'm going to add the purple marks to angle 1. And notice now we have a side in between two angles. So we can say that our triangles are congruent by angle, side, angle. Because we did not want to just prove the triangle's congruent, we got to go further. We got to be careful naming our triangles. So I'm going to name the first triangle, triangle ABC. And that's congruent to, based on my markings, ABC goes no marks, right angle, purple marks. So in the other triangle, we got to go no marks, right angle, purple marks. So that would be EDC for the triangle. And we'll finish this off now. We just proved triangles congruent. So the next reason should be congruent triangles implies. And our new thing in this unit, we saw that it implies congruent corresponding parts. And our statement is just what we wanted to prove, that AC is congruent to CE. So those congruent corresponding parts, the reason we say it that way is it can account for an extra set of congruent sides or an extra set of congruent angles. All right, we're going to go on to proof 3. And we'll give you a minute or two, see if you can do your statements, reasons, and givens, and get the givens down for those first two. So we have parallel lines there. The two things that parallel lines could imply for us are congruent alternate interior angles, which we could get by our zigzag, or congruent corresponding angles. In this case, we have two possible zigzags. We could do a zigzag going this way to get B and D to be congruent to each other. Or we could do our zigzag going this way to get E and A congruent to each other. And in fact, we can do both of those if we want. So as our reason, we'll do our parallel lines implies congruent alternate interior angles. We are pointing at congruent alternate interior angles, so we have to say which ones are congruent. Well, based on the zigzags we just did, we have angle B congruent to angle D. And we'll mark that up in our picture. And then we can just do comma, and we can do our other zigzag, angle A congruent to angle E. And I'll mark those up with 2 arcs. Now, one of the most common errors I see when using the parallel line reason is people forget to say it implies congruent alternate interior angles, and they will just write that it implies alternate interior angles. It is not helpful to us to just have alternate interior angles. We need them to be congruent. Based on our second given, we have the word bisects. After the word bisects is a segment. So we'll do our segment bisector. Implies midpoint. We are pointing at midpoint, so we've got to say which thing is a midpoint and what it is the midpoint of. Well, when they cross AE and BD, they cross at C. So we'll say C is the midpoint of, and it is always the midpoint of what comes after the word bisects. So it's the midpoint of BD. The only time it will be the midpoint of both is if it said they bisect each other. Well, we just talked about midpoint, so now we'll do our midpoint one. Midpoint implies two congruent segments. If C is right in the middle of B and D, then that would mean that BC has to be congruent to CD. And we'll mark those with some tick marks. Well, we now have two angles and a side that is not in between those. So we'll have angle, angle, side congruent to angle, angle, side. And then our proof statement is just what they told us. The two triangles are congruent to each other. Now, there was one other way you could have done this proof. In the purple step there, if you wanted to just do one set of congruent alternate interior angles, you could do that. And then you would need to have vertical angles to get your third thing. Depending which of the congruent alternate interior angles you used, it might have ended up as angle side angle. So if you had kept the B and the D and then done vertical angles, then you would have had angle side angle instead of angle angle side. If you had kept the A and E and then done vertical angles, that would have still been angle angle side. All right, going on to proof 4. Take a minute or two, do your givens. And once you have your givens down, any that are congruent, be sure to mark them up in your picture. So we've got PQ congruent to DE. So I'm going to put a tick mark on each of those. We've got PA congruent to BE. I'll put 2 tick marks on those. And then we got some perpendicular lines. So let's go with our perpendicular lines reason. Perpendicular lines implies right angles. QA and PE are meeting at A. There's 2 angles there, but only one of them is in the triangles. So I'm going to go ahead and label that angle, angle 1. DB and PE meet at B. There's 2 angles there, but only one of them is in the triangle. So I'm going to go ahead and label that too. So we'll have angle 1 and angle 2 are right. And then after that, we'll automatically do our right angles implies congruent angles. And we'll have angle 1 congruent to angle 2. When we go to mark it up in our picture, make sure to mark the congruent angles with a box because they are right angles. So we have 3 sets of things marked up. We've got 2 sides, but the angle is not in between them. So we currently have side-side angle, which we should never be putting in our proof because in general, side-side angle doesn't work. But we saw there's a special case of that if the angle is a right angle. So we're going to be okay because our angle is a right angle. We just have to do one quick step before we can finish it. So we're going to do our right angle implies right triangle. And that means that triangle PAQ and triangle, and we'll be careful naming them here so we don't have to be, so we can just copy it down for the next step. So I went PAQ, so P was in between the red and purple marked sides, so we would have to start with E in the other one. A was where the right angle is, so B would match there, and then D is the other one. And then we'll say R right. But we can now prove our triangles congruent by hypotenuse leg. So we'll have HL congruent to HL, and we'll just say those 2 triangles we talked about in step 7 are congruent to each other. But note, we did not want to get the triangles congruent. We want to get an extra set of angles congruent. So we have to do that new step that we've seen this unit. We just said triangles are congruent. So we'll start with congruent triangles. And we saw that that implied congruent corresponding parts. And in this case, those congruent corresponding parts are a set of congruent angles. We'll have angle D congruent to angle Q. All right, we're going to have you flip back to proof 1. That's back over on page 33. And we are going to give you 10 minutes to see if you can do this proof on your own. And then we'll come back together and we'll go through it as a group. So go ahead, take a bit of time to see if you can do this proof. If you need help, feel free to ask your neighbor and help each other out. All right, so from our givens, we have those purple tick mark segments, congruent. We have an angle bisector implies two congruent angles. C is the middle letter, so that's where the two congruent angles should be happening. I labeled those 1 and 2 in my picture and got them congruent. Well, that used up our givens. We've got a reflexive property, so CX is congruent to CX. From there, we've got an angle in between two sides. So you got side angle side congruent to side angle side. As you named your triangles, the T and the H should be in the same spot, the C's in the same spot, and the X is in the same spot. And then now that we have triangles congruent, and I'm just noticing in step 5, I need my little squiggly above there for congruent. In step 6, we now have congruent triangles, so that can imply congruent corresponding parts. And our statement is just what we wanted to prove. So hopefully you did all right with that proof. Any time left in the period, you can take your Chromebooks out and be working on the extra test review that is on Schoology. The answer key to those proofs are right within the same PDF. Have a great rest of your day.